Privacy meets production. Local AI trade-offs. Running AI workflows locally to dodge GDPR landmines sounds straightforward until the operational realities set in. A UK-based personalized gift business using cloud tools like Midjourney and Leonardo for generating artwork from customer photos is weighing whether to pull everything in-house with a dedicated PC running stable diffusion. The privacy calculus is clear. Thousands of customer faces uploading to US cloud servers feels like a ticking time bomb under European data protection rules, but the hardware calculus is murkier. The proposed setup involves an RTX 3070, which immediately drew skepticism from experienced practitioners. 8 gigabytes of VRAM is tight or impossible for training SDXL, and even inference at production volumes may be problematic. One commenter who ran a comfy UI project to production was blunt. You are going nowhere with a 3070 card, even if you plan on sticking to some light old stable diff model. The consensus points toward a 3090 as the minimum viable option for modern workflows involving Flux or quantized Qwen image editing models. The hybrid approach, training on cloud GPUs like RunPod, then exporting quantized models for local inference, offers a middle path, but throughput constraints remain real. Beyond raw compute, self-hosting introduces challenges that cloud providers quietly absorb. Redundancy becomes paramount. Data should exist in no fewer than 2 geographically separated locations to protect against catastrophic loss. Network security, machine uptime, driver updates, and breaking changes all become the operator's responsibility. The controllability question looms large too. Pumping out images is one thing, but getting precisely what you want from local models requires considerably more iteration than cloud APIs with their polished interfaces. One commenter offered a pointed reminder about the meta workflow. When using LLMs to plan such projects, regularly asking, "How can this go wrong?" is essential. The words chosen in prompts function like coordinates in a high-dimensional space, and overly hopeful framing will yield overly optimistic answers. It's very easy to miss how easily you can be deluded by AI when you're not paying attention to this detail. Branch routing tackles context amnesia. Multi-turn conversational agents have a persistent problem. When topics shift and then return, the model often has no idea what the original context even means anymore because it's buried under intervening discussion. One developer's solution involves tagging each message as stay, branch, or route, then pulling only relevant history per branch, essentially building a conversational graph that preserves topic structure. The practical example clarifies the problem. A user spends 10 messages with a travel agent discussing Paris flights, pivots to 15 messages about hotels, then asks, "What was that cheaper airline you mentioned?" Without routing, the model sees 25 mixed messages and must guess which thread matters. With routing, the system treats the hotel discussion as a separate branch, so airline queries pull only from the flight thread. Cleaner context means fewer errors and eliminates the need for giant context dumps that stress token limits. The implementation uses an LLM call to classify message intent. Yes, it's LLM to manage LLM, but it works for this narrow task. Embedding-based classification is the planned next step. At roughly 2,700 lines of code, the developer acknowledges it's probably over-engineered, with edge cases yet to surface. The key differentiator from manual branching interfaces available in front ends like OpenWeb UI is automation. The system detects drift without requiring user intervention. Commenters raised valid concerns about the approach. If fact extraction misses something during branching, the model may seem forgetful. When users ask questions that synthesize across multiple decomposed subtopics, how do A, B, and C interact? Extracted facts may lack sufficient detail for useful analysis. The developer's answer: merge operations. The system can detect when a query requires multiple branches and reassemble context across them, treating the conversational graph not as strictly tree-structured, but as branches that can reconnect when topics converge. Section no-code fine-tuning gets a Streamlit interface. The endless rewriting of custom pipeline scripts for LLM fine-tuning has spawned a new Python package offering a UI-driven workflow. Upasak, currently in pre-release, wraps Hugging Face transformers in a Streamlit interface covering the full fine-tuning lifecycle, from dataset preparation through training to model export. The standout feature is data sanitization, detecting and handling personally identifiable information including names, addresses, emails, phone numbers, API keys, and government identifiers before training. This addresses a critical but often overlooked step in responsible LLM development. The system offers both rule-based and optional AI-based approaches with manual review for uncertain detections. Dataset handling is similarly streamlined. The tool supports 6 or 7 different schemas and automatically recognizes and applies templates without requiring users to pre-process or rename fields. Current limitations include support only for Gemma 3 text models, though Llama, Phi, Qwen, and Mixtral are planned for future releases. The tool offers LoRa training with configurable rank, alpha values, dropout rates, and target layer selection, plus full fine-tuning for those with sufficient compute. Live training and validation loss graphs displayed directly in the app, reducing dependence on external experiment tracking platforms like CometML or Weights and Biases, though integration with those tools remains available. The reviewer tested training on cloud GPU servers and found the pre-release package performant enough for real use, despite some minor UI component issues. The project appears positioned for contributors interested in expanding model support and addressing remaining rough edges. Decentralized training enters production. The idea of training large models across distributed consumer hardware has moved from theoretical curiosity to deployed reality. Hermes 4.336b, a fine-tuned model from new research, was trained entirely using Psyche, an open-source tool that splits training across multiple remote GPUs, allowing them to join and leave the swarm mid-run. This represents what's claimed as the largest model ever trained in a decentralized manner. The design addresses practical constraints. GPUs can join and leave during training, runs can be paused and resumed, and the system aims to maximize cost savings by leveraging rented GPUs during off-peak hours. Blockchain technology handles verification to prevent malicious participants from poisoning training with fake gradient updates. Notably, Nose trained a second copy using traditional centralized infrastructure and found the decentralized version achieved comparable or better benchmark results, though this raises questions rather than answers them. Skeptics point to several unanswered questions. There's no published efficiency estimate comparing Psyche training to centralized approaches, nor information about how many gradient submissions were rejected during training. The unexplained benchmark advantage for the decentralized version seems counterintuitive. A rigorous comparison would expect similar results, making significant differences sus, as one commenter put it. The broader implication is tantalizing. Coordinated communities could potentially pool consumer hardware to train custom models and apes together strong approach to AI development. The technology could also benefit individual developers using spot instance GPUs at low prices without the anxiety of interrupted training runs. Interest in this space dates back to the announcement of Distro, distributed training over the internet, over a year ago, though attention has waned amid the noise of the AI hype cycle. Turning autoregressive models into diffusion LLMs. A new open recipe allows converting any autoregressive language model into a diffusion language model with minimal compute. The tiny A2D series, built using the DLLM library, enables parallel token generation and infilling capabilities not possible with standard left-to-right generation. The appeal of diffusion LLMs lies in their generation dynamics. While autoregressive models generate one token at a time, sending all model weights from VRAM to GPU for each token, diffusion models can calculate multiple tokens per weight transfer, dramatically reducing the waiting time that dominates inference on memory bandwidth-limited hardware. This architectural difference could translate to meaningful speedups for users running models locally. The practical caveat is significant. Conversion requires complete post-training for inference. As one commenter clarified, you first convert the base model, then need to fully retrain it, making this a problematic tool for any larger model where such retraining is prohibitively expensive. The release checkpoints include relatively small models like Qwen 3.0.6b Diffusion BD3LM v0.1. Speculative possibilities emerge from this technique. If someone distills knowledge from a model like DeepSeek into a smaller Quen variant and then converts it to diffusion format, the result might offer high-quality inference on increasingly modest hardware. Memory constraints remain. The architecture change doesn't reduce model size, but the generation speed improvements could make smaller diffusion models competitive with larger autoregressive ones for certain tasks. Building AI agents from Django to memory systems. A detailed tutorial series walks through constructing AI agents with multi-layered memory using Django, Llama, and Pydantic AI. The architecture separates short-term memory, current chat with auto-pruning, from long-term memory using PG Vector for RAG-style retrieval of relevant information from past conversations. Summarization creates condensed memories of old chats, while structured memory uses tools to save and retrieve data from Django models, demonstrated with a fitness tracker example. The technical stack combines Django and Django Ninja for the web framework, Llama for running models like Llama 3 or Gemma locally, Pydantic AI for agent logic and tools, and PostgreSQL with PG Vector for vector similarity search. The guide emphasizes explaining the why behind design decisions rather than just the implementation steps, making it more educational than typical tutorial content. The memory hierarchy addresses a fundamental challenge in agent systems, maintaining context across interactions without overwhelming context windows or losing important information. Short-term memory handles the immediate conversation. Long-term memory provides relevant historical context via semantic search, and summarization prevents indefinite storage growth while preserving essential information. This layered approach mirrors how production agent systems must balance immediate responsiveness with long-term coherence. Synthetic test data, quality over quantity. Generating synthetic test data for LLM applications has become its own discipline, with practitioners developing systematic approaches that go beyond naive prompting. The core problem is familiar. Building an agent requires testing across hundreds of scenarios, but manual test case creation is slow and misses edge cases. Effective synthetic data generation starts with context grounding, feeding the generator actual documentation, system prompts, and example conversations rather than generic category descriptions. The difference between generate customer support queries and generate queries based on this product documentation is substantial. Multi-column generation proves essential. Generating not just inputs but expected outputs, user personas, conversation context, and edge case flags creates test cases that actually exercise the system meaningfully. The iterative refinement loop. Generate 100 examples, manually review 20, identify patterns and failures, adjust generation, repeat, acknowledges that perfection in one shot is unrealistic. Edge cases require explicit prompting because LLMs naturally gravitate toward happy path scenarios. Programmatic validation, JSON schema checks, length verification should precede expensive LLM-based evaluation. The most common failure mode is synthetic data that's too polite and well-formatted compared to real users who communicate with typos, incomplete thoughts, and messy phrasing. Results from this approach cut test case creation from 2 to 3 days to roughly 30 minutes for 500-plus cases. Quality reaches approximately 80% of handwritten test cases, sufficient for pre-production testing where comprehensive coverage matters more than perfection in each individual case. Prototype-driven UI development with Claude Code. Large codebases, often exceeding 1 million lines, present unique challenges for AI-assisted UI development. A Claude Code command designed for prototype generation addresses this by creating multiple UI variants with controls for comparison, enabling rapid iteration on highly interactive components. The workflow begins with extensive context gathering, features, interfaces, actions, buttons, badges from source components, business goals, UI libraries and CSS strategies, UX patterns, relevant type definitions. The system enriches this with UX best practices from trusted sources before generating shared mock data and multiple component variants. Each variant is created by a separate sub-agent with different prompts emphasizing different strategies: minimal inline, status card, split summary, action bar, progressive disclosure, while addressing core requirements. The key insight is federation. The main agent operates as an orchestrator, delegating work to subagents that run concurrently where possible. This approach, advocated by practitioners like Indie DevDan, allows the system to leverage multiple instances of patterns rather than narrow single examples. Specialized UI subagents can review results in browser via MCP, Model Context Protocol, and iterate until satisfied with the presentation. The output includes a preview URL, relevant data sources, key features, and a variant list with approaches and prescribed use cases. The resulting architecture, prototype files, mock data, route pages, enables side-by-side comparison of design approaches before committing to implementation, dramatically accelerating the design-to-development feedback loop for complex enterprise applications. Section LLMs excel at expected, struggle with serendipity. Can large language models surface genuinely unexpected but valuable insights from structured scientific knowledge? Researchers built a formal serendipity metric, combining relevance, novelty, and surprise, and tested frontier models on a biomedical knowledge graph used for drug repurposing. The findings illuminate a fundamental limitation of current AI systems. The results are stark. LLMs excel at retrieving known pathways, staying close to the center of the graph where answers are well understood and structurally obvious. But when asked for serendipity, not just the right answer but the interesting one, performance collapses. Even the strongest models barely identify non-obvious but plausible candidates. They follow the rails laid down for them, but struggle to wander intelligently. The analysis reframes what LLMs fundamentally are: high-speed pattern matchers and retrieval engines over known knowledge, valuable when constrained by human-designed search spaces and validation frameworks. Serendipity requires pattern violation detection plus abductive leaps. Judgment, taste, sensing that a strange connection might matter even when evidence isn't fully formed. This remains distinctly human territory. Commenters pushed back on the absolutism. One argued that prompting with anti-questions, querying multiple LLMs, and including non-traditional human community sources can surface low-propensity answers comparable to qualitative research with humans. Another raised AlphaFold as a counterexample of genuine AI discovery, though the distinction may be that AlphaFold predicted something physically existing but unknown, while serendipity requires imagining connections that don't yet exist but could. CodeLayer and human-in-the-loop AI development. HumanLayer has evolved into CodeLayer, an open-source IDE for orchestrating AI coding agents with battle-tested workflows for solving hard problems in large, complex codebases. Built on Claude code, it promises keyboard-first workflows designed for speed and control while scaling AI-first development to entire teams, without devolving into a chaotic slop fest. The multi-Claude capability allows running Claude code sessions in parallel with worktree support and remote cloud workers. User testimonials claim 50+% improvements in productivity and token consumption through what one founder describes as a superhuman-style approach. The team behind CodeLayer originated the term context engineering in April 2025 and has developed frameworks including a 12-factor methodology for LLM applications. The broader vision positions this as infrastructure for outcomes rather than tools. Enterprise services include tailored workflows, custom integrations, and expert engineering support aimed at making everyone a 100x engineer. Whether such multipliers are achievable or marketing hyperbole remains to be seen, but the open-source foundation allows independent evaluation. Cloud-hosted versions are coming, with waitlist sign-up available. Security tools, Cobalt Strike automation, and Next.js scanning. The offensive security tooling ecosystem continues to mature with new automation frameworks. CSBot provides YAML-based workflow automation for Cobalt Strike operations, executing complex operational workflows against beacons using simple templates. Features include conditional logic based on beacon metadata, success-failure branching, interactive beacon selection, and support for shell commands, PowerShell, BOFs, beacon object files, and file operations. The tool addresses real operational needs: visual beacon pickers, easy-to-read and version-controllable workflow definitions, complex conditional execution with if-else logic, and concurrent action execution. Variable references allow chaining action outputs, and conditions can evaluate user, OS, and privilege information. The project is in early active development with some known issues around BOF output and shell execution completion handling. On the defensive side, React2Shell Ultimate provides comprehensive scanning for CVE 225-66478, a critical RCE vulnerability in Next.js applications using React Server components. Version 2.0 adds advanced exploitation capabilities, sophisticated WAF bypass techniques, a web interface, and improved debugging. Multiple scan modes, safe, RCE, version comprehensive, allow appropriate testing intensity with batch scanning and JSON output for automation. The tool is explicitly for authorized security testing only, though such disclaimers do little to prevent misuse. App Store sanctions compliance under scrutiny. Apple and Google face questions about sanctions enforcement after dozens of apps for U.S. blacklisted entities remained available in their app stores. The apps are associated with Russian banks sanctioned after the 2022 Ukraine invasion, a Chinese construction company operating in Xinjiang, and a Houthi-linked entity in Yemen. Legal experts characterize the continued availability as a violation of law. The issue highlights the practical challenges of platform-level compliance at scale. App stores host millions of applications, and sanctions lists evolve continuously as geopolitical situations change. Automated detection of sanctioned entity connections isn't straightforward when apps may use subsidiary names, translations, or other obfuscating identifiers. The scrutiny arrives as both companies face broader regulatory pressure on multiple fronts. Portugal shields security researchers from prosecution. Portugal has updated its cybercrime law to exempt security researchers from prosecution, adding to the growing list of jurisdictions providing legal safe harbors for responsible vulnerability disclosure. The change recognizes that criminalizing security research creates perverse incentives. Researchers who discover vulnerabilities face legal risk for reporting them, potentially leaving flaws unaddressed. Such exemptions typically require researchers to follow responsible disclosure practices, acting in good faith without malicious intent, minimizing harm, and coordinating with affected vendors. The specifics of Portugal's implementation will determine how practically useful the protection proves. Similar protections exist in varying forms across the EU, US, and other jurisdictions, though enforcement varies and researchers often remain cautious about relying on legal safe harbors when discovering vulnerabilities in systems operated by litigious organizations. Microsoft proposes Hornet LSM for secure eBPF. Microsoft has submitted a patch set to the Linux kernel proposing the Hornet Linux Security Module, LSM, focused on more secure eBPF programs. This might surprise those unfamiliar with Microsoft's Linux contributions. They rank number 11 among kernel contributors, driven by Azure's composition being over half Linux. eBPF, Extended Berkeley Packet Filter, is a virtual machine in the kernel, allowing user space programs to execute in kernel space. Originally designed for packet filtering, it now handles load balancing, system auditing, security, intrusion detection, and more. This capability has also made eBPF attractive for malware and spyware applications. While existing signature schemes restrict eBPF programs, Hornet addresses potential time-of-check, time-of-use, TOC 2 attacks and current protections while enabling stricter checks and auditing. The patch is currently a request for comments, RFC, awaiting community review. The December patch Tuesday brought 57 vulnerability fixes from Microsoft, with one actively exploited in the wild. CVE 2025-8110, an escalation of privilege flaw in the Windows Cloud Files mini filter driver, was a use after free, allowing attackers to gain system privileges. Mini filters are kernel drivers that attach to file system software to monitor or modify file operations, making such vulnerabilities particularly dangerous. Section Gogs vulnerability exploited. Project appears unmaintained. Researchers at Wiz discovered active exploitation of CVE 2025-8110 in Gogs, a self-hosted Git service written in Go. The vulnerability bypasses a previous path traversal fix by exploiting symbolic links, legal in the Git protocol, but not accounted for in the security patch. Attackers can create symlinks pointing outside repositories and then use the HTTPS file API to write arbitrary files. The exploitation is widespread. Of approximately 1,400 Gogs instances exposed to the internet, Over 700 show signs of compromise through repositories with randomized names. The attack chain involves adding a symlink to git config, overwriting it to define a malicious SSH command setting, and installing supershell malware for ongoing remote control. Even more instances may be compromised with evidence hidden. Most troubling, the vulnerability was discovered in the wild in July and reported to the Gogs project, but as of December remains unpatched and unacknowledged. 5 months of active exploitation without maintainer response suggests Gogs is effectively unmaintained. Organizations using Gogs should consider migrating to active forks that aren't vulnerable to this attack. Causality Analysis Framework for LLM Security. A new paper from Singapore Management University introduces a unified causality analysis framework for systematically investigating security vulnerabilities in LLMs. Unlike previous surveys that descriptively catalog jailbreak attacks and defenses, this work provides tools to analyze why such vulnerabilities arise by uncovering causal mechanisms governing safety behavior. The framework supports analysis at 4 levels. Token level, how input tokens affect outputs via counterfactual interventions. Neuron level, identifying sparse, causally critical neurons. Layer level, tracing causal influence through transformer layers. And representation level, exploring how embedding geometry encodes safety boundaries. Key findings include that safety mechanisms are highly localized, concentrated in early to middle transformer layers with only 1 to 2% of neurons exhibiting safety-critical roles, and that targeted interventions on identified components reliably alter safety behavior. The practical implications are significant. Causal features enable detection success rates above 95% across jailbreak, hallucination, backdoor, and fairness tasks. The paper's taxonomy covers both causality-based attacks like neurostrike, which identifies and manipulates sparse safety neurons, and defenses like erase and check, which systematically removes tokens to identify harmful prompt components. The framework code is publicly available, establishing a reproducible foundation for causality-based security research. Section Llama Management. The llama.cpp server now ships with model management capabilities, allowing dynamic loading, unloading, and switching between multiple models without restarting, bringing a llama-style convenience to the lightweight, OpenAI-compatible inference server. The feature uses multi-process architecture, where each model runs in its own process, isolating crashes. Starting the server in router mode auto-discovers models from the llama.cpp cache, or a specified directory of GGUF files. Models load automatically on first request and unload least recently used when hitting the configured maximum, default 4 models. The architecture supports on-demand loading with the model field in requests determining which model handles each query. Subsequent requests to already loaded models respond instantly. Configuration options include model directory paths, maximum concurrent models, per model settings via presets.ini, and inherited settings from the router process, context length, GPU offload layers. The web UI also supports model switching through a drop-down selector. This makes A/B testing model versions, running multi-tenant deployments, and switching models during development substantially more practical. Mistral releases Ministral 3 family with vision. Mistral AI has released Ministral 3, a family of efficient language models with vision capabilities designed for edge deployment. The 8B parameter instruct version fits in 12 GB VRAM in FP8 format, with even lower requirements if further quantized. Key capabilities include strong multilingual support across dozens of languages, native function calling, and JSON output for agentic applications, and a 256K token context window. The family spans 3 sizes, 3B, 8B, and 14B parameters, each available in base, instruct, and reasoning variants. Benchmark results position the 8B instruct model competitively. 0.787 on IM25, 0.AM24, 0.668 on GPQA Diamond. On instruct benchmarks, it achieves 0.509 on Arena Hard and 66.8 on Wild Bench. The vision encoder adds 0.4B parameters to the language model core. Recommended deployment uses VLLM with specific flags for tool calling support. Best practices include using low temperature, below 0.1 for production, keeping toolsets minimal and well-defined, and maintaining aspect ratios close to 1:1 for image inputs, avoiding overly thin or wide images. The Apache 2.0 license permits commercial use, positioning these models for broad deployment in resource-constrained environments. Speech recognition for dialects and whispers. GLM Nano 2512 is a 1.5B parameter speech recognition model optimized for challenging acoustic scenarios that trip up conventional systems. Beyond standard Mandarin and English, it specifically handles Cantonese and other Chinese dialects, addressing a significant gap in dialectal speech recognition. The model's low-volume speech robustness targets whisper and quiet speech scenarios where traditional models fail. This training focus enables accurate transcription of extremely low-volume audio that would otherwise be missed or garbled. Benchmark results show the lowest average error rate, 4.1, among comparable open-source models, with particular advantages on Chinese benchmarks including Wenet meeting, reflecting real-world meeting noise and overlapping speech, and A-Shell 1. Integration uses the Transformers library, with forthcoming support for Transformers 5.x and inference frameworks including VLM and SG-Lang. The combination of dialect support, quiet speech handling, and competitive accuracy on standard benchmarks positions the model for practical deployment in environments where existing ASR solutions underperform. De-distilling image models for better fine-tuning. A creative workaround addresses a common frustration with distilled image generation models. They're optimized for fast inference, but resist fine-tuning. The Z-Image Turbo model is a de-distilled version of Z-Image Turbo, fine-tuned on images generated by the Turbo model specifically to break down the distillation. The practical benefit: LoRa's trained on the de-distilled version should remain compatible with the original Turbo model, and the de-distilled version can be fine-tuned much more effectively than the Turbo variant. For inference, the model works with low CFG 2.0 to 3.0 and 20 to 30 steps, compatible with CFG normalization. Both Comfy UI and Diffusers versions are available. The motivation is refreshingly honest. Why not just use the base model? It wasn't released yet as of the time of this writing, and I am impatient. This kind of practical workaround, using synthetic data to reverse engineer desired properties, represents the improvisational spirit that drives much open-source AI development when official releases don't meet community timelines or needs. Open Web UI gets complete API documentation. The Open Web UI Python client now has comprehensive API documentation covering every endpoint, model, parameter, and dictionary key, filling a critical gap that previously forced developers to spelunk through source code. The documentation was auto-generated using kilocode with Devstral 2, revealed as Spectre, taking approximately 8 hours and consuming 61.3 million input tokens across 1,378 requests. The generation process involved tests that would fail if any field or endpoint lacked a docstring, extended to fail if dictionary attributes lacked dict fields headings. Subagents explored both front-end and back-end code, locating every use of each model, endpoint, or attribute to identify expected keys and reason about meanings and side effects. The orchestrator restarted 4 times due to reaching maximum context, with each subagent using around 100K tokens. The longer-term goal is enabling Open Web UI agents to manage their own hosting instance, modifying system prompts, creating tools on demand, handling administrative functions normally requiring front-end interaction. A tool providing API access has already been published, described by its creator as extremely dangerous but functional in testing. One commenter captured the recursive absurdity: an AI reading undocumented code to write instructions for another AI to control the AI. It's the circle of strife. Go optimizations for high-volume services. Building services that stream Postgres replication data into Elasticsearch creates a stress test for Go's memory allocator, garbage collector, and JSON handling. The constraints are unforgiving. The service can't stop reading from the replication slot, or Postgres disk grows unboundedly, and can't buffer unlimited data in memory, or the heap balloons. The goal is stable latency and memory under sustained high volume. Switching from the standard libraries encoding JSON to JSON-ITER provides faster encoding-decoding with less reflection overhead, with wins most visible when serializing many small documents at high frequency. The trade-off requires careful testing. JSON-ITER behaves differently in edge cases around nulls and omitted fields, particularly with libraries like Garegu null.v4. The omits_arrow tag doesn't work identically to standard library behavior. Omitempty produces more consistent results. Sync.pool addresses the flood of short-lived allocations from replication events, structs, JSON encoding buffers, intermediate slices, and maps. Pooling reusable buffers for bulk requests and small metadata structs significantly reduces per-event allocations, bringing down GC frequency and pause times. The key discipline: only pool objects frequently allocated and easy to reset. Avoid pooling objects with complex lifecycles or embedded contexts. Starting with Go 1.25, experimental GC options promise reduced latency spikes by scheduling GC work more smoothly. For pipelines that must keep up with replication slots and bulk indexers, slightly higher steady-state memory usage is acceptable if it avoids GC pauses that temporarily slow ingestion. But GC tuning should be the last optimization step, applied after profiling and streamlining allocations to shift balance rather than compensate for fundamental inefficiency.